Was impossible to do for computers earlier. It was just impossible. And he said, if we can take sensing, the cameras and the, make stuff tactile, and then start building arms, you can completely kind of rethink automation. So that was kind of, that single dinner, I pulled out my checkbook and I was desperate because that experience of one of the world's foremost minds talking about this in a story form, like about closing a bottle cap, just blew me away.
It's a simple idea that extends forever.
Oh my God.
And now, of course, once the robots network, the activity of one contributes to the learning of all.
That's right.
So you've got 100 robots on the floor or 50 robots in 8 locations around the country. Each one of them is taking information probably to some cloud-based core that's going to merge that and then do over-the-air software downloads to the rest. So they just create this virtuous cycle.
That's right.
Now, it took longer than you thought to make this work, admittedly.
Yeah.
The cycle on this was sort of long, 7, 8 years to ship, right? Why was that?
It's hard. And building humans is harder. We were trying to build, if you go to, there's a video of it maybe somewhere in the back, you'll see, it has a form factor of a human. It has a hand, it has 2 hands, it has a face, it has shoulders and a bunch of stuff. But more importantly, it has a brain. And in those days, there was no TensorFlow. We had to write our own behavior trees. We had to write our own neural nets. Imagine trying to compute all that on a small device somewhere, and we want to kind of get the price point. The way we designed this was we had to get the price point to operating at around $2 an hour.
Okay.
So if you think about a human without needing any medical insurance, if somebody can work at $2 an hour to do simple tasks, can you redefine manufacturing economics and bring jobs back to the US? Actually, the company was first called Heartland Robotics. He was so prescient. This is 2009. He said, I'm going to revive America's heartland by building this stuff. And he called it Heartland Robotics, and now, because it's a global company, we had to rename it Rethink Robotics. But
so
that was the idea.
You got to connect a few more dots here. I'm going to make robots that can work so cheaply they undercut a Chinese worker, get employment for people. How?
So if you look at a manufacturing line, in China especially, or you look at Apple, the Apple assembly line at Foxconn, you see 50 people working.
Yeah.
And they're all doing their task and moving that phone to the next place who is doing their task. And then there are 4 or 5 people roaming around looking at data, analyzing the data, and managing the stuff. So we said, instead of bringing those 50 jobs back, if we can bring 40 jobs, if we can bring 10 jobs back,
right,
and all those 10 jobs are at $45 to $50 an hour, so higher paid jobs, and replace the lower paid jobs with machines,
that thing, right. And then there's ancillary local shipment or coordination or upstream activity that revives when you do that. You point this to the highest value areas, and associated areas get created around it. That does make sense.
So it was such a monumental task. In 2009, the cloud was still beginning. AI, we were in the nuclear winter of AI. We may not have fully come out of it then.
I'll push back on that in a second.
In 2009, I'm talking about.
Okay.
And it was really before any of this explosion began. So it took us a while to get the first product out. It's like how Tesla came out with the Roadster before they came out with the Model S. We came out with a product called Baxter, which was a 2-handed monster that looked like Shaquille O'Neal. It was huge, but wasn't very powerful. So we kind of shrunk the form factor down and made it better. So it took us a while to kind of go through that. So as a VC, I learned that when you take on, I'm not worried about ambitious projects. I just learned that you have to be more patient with it.
But do you think that kind of 7-8 year curve pertains in robotics, or has the learning been shared and the need been seen and the associated supply chains been lined up so now it becomes 5 and eventually 3?
I think so. I think it's it took us a while to build the brain. Now with what you guys are doing at Google, that'll compress. That time will compress. It took us a while to build the supply chain. Now that we have set the supply chain up, the next competitor who's coming behind it will make it cheaper. So yeah, it'll compress.
One of the things I learned in the days of the optical business in the late 90s was throughout tech, there's this curve of what kind of starts as individual genius or scientific insight or artistic expression, whatever. It's this aha, eureka moment. The experiment may have it. But then you figure out other experiments that reinforce it, and that's kind of the falsifiability that makes it a working scientific principle. Then you figure out how to do it repeatedly in other environments, and non-specialists can do it, and that's sort of the engineering days. And eventually that's a mass engineering, and then it's done at cost where it meets a broad market, and it just comes right down into mass manufacture. And I think AI came out of the winter because of the explosion of unstructured data and the collapse of computing prices. And it revived, and it's now sort of at the engineering point on the curve and heading into mass usage. Where would you put robotics in that sort of
I think we are going through
art to science to engineering to mass
We're going through 2.0. So we went through that curve once with industrial automation. We are seeing the kind of early signs of manufacturing on the industrial automation 2.0 phase. You're seeing stuff that is cheaper. Earlier the robot, if you remember any movie about Ford or Tesla, you'll see it's a common refrain. You'll see the screen. The screen will have a bunch of robots that are either spray painting or actually manufacturing some stuff, and the cars are going through the assembly line. What don't you see in that picture? You don't see humans.
Yeah.
Because robots are not safe. They're caged, and you don't. If a human's in the machine in the cage, the robot's turned off because they're not. They don't understand.
They have no elegance.
They don't understand that there's a human there. This next generation of industrial robots, including Rethink, fully understands that the human is the master. And so when they see a human, that's the reason why they have eyes. They automatically slow down. And even if it's moving at speed, if it hits a human, it automatically goes limp. So it won't hurt the human. So I think collaborative, smart, intelligent robots are just coming into manufacturing.
And the other element they will learn, and this is interesting to think about, is they will begin to adjust to their operator. People will optimally work with them in different ways, and they'll learn that. And through over-the-air software downloads or just inherent piece parts built differently, adjust themselves to that worker.
Yeah.
And possibly even train that worker in new skills.
That's right.
So they'll become educational devices as well.
It's just what we're entering into is just a fascinating world.
So once you become a robot guy, I mean, you get a specialist, you get a specialty in any VC, and you start getting swamped with pitches.
Yeah.
What are you getting pitched nowadays that you feel has been overdone or it's not a hard problem anymore? And what are you seeing? What kinds of problems are people raising that you think are really exciting and worth working on?
We just look for, we don't think we are smarter than the market. At CRV, our ethos has always been that great entrepreneurs create great opportunities. So we are always pursuing great entrepreneurs and their ideas, not our ideas. I think we feel that even if a great entrepreneur shows up in our offices and says he's going to build the next generation, he's going to take down AWS, we'll take them very seriously because of our understanding of that person. So no idea is a bad idea. What has got overplayed though is there's too much capital chasing kind of niches. And those niches we see are collapsing. So for example, I'm a SaaS investor. I invest in SaaS all day long. But nowadays, just building a SaaS company is not enough. You have to bring something else to the party. Else there are companies from all over the world who have Google and AWS to kind of ride on. So infrastructure is free. They can just copy your product and build something very, very fast. So I think looking at just pure SaaS companies or pure stuff that doesn't have either a data edge or an AI edge or some other edge that they're bringing to the party becomes a little difficult as a VC to see.
Tell me your last really inspiring conversation. What did somebody say that kind of blew your mind?
I met a Chinese entrepreneur recently. She was a principal engineer at Cisco. And she then worked for Huawei in China. And then she came back here. And she said, so I said, when you look at the cloud, what problems do you think exist? She said, cloud is a fantastic infrastructure layer because it is elastic. But storage is elastic, compute is elastic, networking is not elastic. She said, why isn't networking elastic? And why can't we make networking elastic?
Isn't SDN a kind of elastic networking or not?
Yeah, but in the cloud, when it's definitely inside the enterprise, but when you think about the cloud.
Taking it to a global scale.
Yeah.
And that's what she's building?
She wants to build, yeah. But it's
an
interesting, it's a very tough problem.
Interesting and tough problem.
That's taking on Cisco. That's an interesting problem to solve.
Are most of the robot approaches you're seeing having to do with manufacturing, or do you get into other stuff like surgery or high-end autonomous vehicles?
We have invested in all of them. We have a company called, a product called Jibo that is coming out, which is started by an MIT scientist called Cynthia Brazil. Cynthia is one of the world's foremost experts in human-computer interaction. And she's building a robot for old age and companionship. So think about Google Home, except in a kinder,
with
gentler,
arms and legs.
Form factor. You'll see 2 hours from now, one of our entrepreneurs, Vikas Gupta, is talking about Wonder Workshop, and he's building robotic toys. But toys are, his passion is to teach his 6-year-old daughter software engineering. So he's using robots to teach software engineering. So I think it's just robots as a form factor are very fascinating.
You're not running out of ideas or spaces, and the work will follow. People
Absolutely.
will find things to do with
Absolutely.
this. I think that's what we have time for.
Great.
Thank you very much. Okay.